Here we have an equilateral triangle. Here there are a lot of equilateral triangles we can see on this table, and there are 1, 2, 3, 4 and 5. 5 equilateral triangles are there here on the table. Now let us see what this boy will let us see whether these equilateral triangles are congruent or not. Check whether they are congruent or not. Whether they are congruent or not, you check. How to check whether they are congruent or not? We can check whether they are congruent or not by overlapping them, by putting them one on the other. By putting them one on the other, yes, like that. If you put them one on the other, you can check whether they are congruent or not. Yes, all the triangles are very much congruent to each other. Now what properties can we study by using all these equilateral triangles? Let us see. So take two equilateral triangles and form a shape. What shapes can you form? So here we have an equilateral. We added two equilateral triangles. By adding two equilateral triangles, here a shape is formed. What is this shape? This shape is a its shape is a parallelogram, and in this parallelogram, if you see, all the sides are equal. If you see, all the sides are equal. If all the sides of this parallelogram are equal, then if all the sides are equal in a parallelogram, then this parallelogram becomes a rhombus. See, this side and this side and this side, all the sides are equal. So it is a parallelogram. And in the parallelogram, now we can see the diagonal also. In the parallelogram, we can see the diagonal also. Yes, that one is the diagonal. The split that is there, that is the diagonal. If you see that the diagonal of the parallelogram divides it into two congruent triangles. So if you just put them on one another, then they coincide with each other. So they are two congruent triangles. So we can see the what do we say? The theorem that the diagonal of a parallelogram, it divides it into two congruent triangles. Now if you see, moreover, now I think we can make it some other shape also. You make a triangle with by using the remaining one. Yes, this boy is making a triangle here with four of the triangles, four of the equilateral triangles. Here he has taken four equilateral triangles. By using four equilateral triangles, we have here we can form a triangle. And in this one, this side is equal to this side, and this side is equal to this side. So this point is midpoint, and here also this point is midpoint. So now if you see line joining the midpoints of these two triangles, then this line is parallel to third side. The midpoint and this midpoint, if you join these two midpoint, if you can easily observe that this and this side and this point, this line, this split, both are parallel to each other. So this verifies, or this proves the midpoint theorem what we study in our class 9. So and not only that one, in this way, if you see line joining, this is the midpoint of this side, this is the midpoint of this side, this is the midpoint of this side, and each one, now if you join all the midpoints of all the three sides of a triangle, the triangle which forms inside, which forms by joining the midpoints of this one, the sides of a triangle, is 1/4 of the whole triangle. 1/4 of the whole triangle. So this theorem also we can verify it.